Okay, let me introduce myself. My name is Dmitriy Uglanov. I'm associated professor of Department Heat Engines and Heat Engineering, and also I'm Vice Dean of Faculty Aircraft Engines and Power Plants. So I would like to make a small presentation to you and discuss together with you about energy systems, energy power plants, and some moments about using of renewable energy source. So some words about my university. Our university, Samara State Aerospace University. It was named academician Sergei Korolev until 2015, but in 2015 we have connected with another university, and now we have named a name Samara National Research University. And Samara, it's one of the biggest city of Russia. So it's you can see it's in east from Moscow, about 1,000 kilometers from Moscow. So and now Samara is one of the biggest city in Russia with a population about 1.2 million people. Our city was founded in 1586, and now it's one of the fastest developing cities in Russian Federation. And major areas of economical development are metal processing, mechanical, and space engineering. And for this reason, one of the symbols of our city is a rocket, because I think every second rocket is launched in Russia, it's made in Samara. So we have good and deep cooperation with different universities, and now main areas of research and education activities you can see here. And so, of course, space engineering, aeronautics, aerospace engine construction, dynamic and vibroacoustics, and perspective material and technologies, laser systems, information technologies, of course, space informatics, physics, chemistry, gas dynamics, and of course, energy. So, and for this reason, our faculty deal with also not only aircraft engine, but also with power engineering. And for this reason, we have some specialization education program which deal with energy and energy saving processes. So let's start our talking about energy and what we have in this moment in the world. So of course, if you have any questions, don't hesitate, ask me. You can send maybe messages, or maybe you can do it in voice. Okay. So I think energy is very interesting, because we understand that energy helps us to live in comfortable conditions. Yeah. And we cannot imagine that we don't have electric energy and heat energy, or especially in hot time conditioners. Yes. And all things demands for creating comfortable conditions, some electric energy. So, and you can see, despite that now, of course, a lot of talking about renewable energy, but if frankly speaking, about 90% of energy which we use in the world deals with is produced by traditional energy. So in this moment we have three main types of power plants. Yes, it's a thermal power plant. Yes, it also hydro power plant and nuclear power plant. So, and you can see shown very well that we have it's taken, this figure is taken from some open sources that you can see in 2019 volt electricity generation by a source is shown here. Yeah, and we can see at this moment in the world more energy is received by using of coal. Second one, natural gas, then hydro, fuel oil, yes, nuclear energy about 10%, and only 10% it's a renewable energy. And for this reason, I would like to start our discussion today from traditional energy. Of course, first of all, and main energy we receive from using thermal power station. You can see here it is. If we make summarizing, yeah, 37% plus 24, yes, it's about 61, and plus fuel, well, it's about 65% of all energy in the world we receive by thermal power engineering. It's a this I think you know that steam power plants also it's possible to call such power station. They have been started from the middle 19th century, yeah. And in the beginning, the efficiency of such power plants they used and for railways, yes, steam and some ships. It was not very high efficiency, about 5%. But now, very modern thermal power stations have very high efficiency, about 40%. So it only if we speak about electrical energy, because it's possible also to receive in hot heat energy. You can see that traditional station consists some main elements. So we have a boiler, yes, some turbine, yeah, which and the working substance which is used in thermal power station. Usually it's water and water steam. So turbine is connected with electric generator, and from electric generator we receive with you energy. So also here it is condenser, and here it is, of course, must be put pump system, and we have and we use here this Rankine cycle. Yes, if we speak with you about thermodynamic. So and in steam generating cycle, heat is used to boil water in large pressure vessel. So, and you can see it's shown that we, for example, we receive here coal and put it here in this boiler. And boiler, we have a heating process and evaporation process of water. Water have a high pressure and high temperature, and we send it to turbine. So, but after turbine, we have second heat exchange. We have two heat exchangers. Here, boiler, and second one condenser. And the main purpose of it, we need to create condition when steam becomes water, and it becomes liquid. In liquid water, we use pump, as I said, here it is pump, yeah, and to increase the pressure again. This condenser helps us to receive also heat energy, as I said, and total power, total efficiency could be imagined like electric energy plus heat energy and divided energy, which we put here in burning process of coal, yeah. Here it is. W means power, electric power, and here it is heat energy, and we receive total efficiency about 70, 75, 80%. It's total with the heat and electric energy. But if we speak about only electric energy, it's about 40%. So I think some maybe interesting moment I show here. So here it is. It's shown. You can see more simple scheme of such thermal power station. It consists of 2 turbines, yes, and we have some additional heat process to preheating between 2 turbines, and it helps us to increase efficiency. And but Rankine cycle, you can see it shown very well. It's possible to draw only one stage, and in this case it will be like this one. Yeah, and 1, 2 means it's a pump. You can see here it is pump. It's 1, 2. Then we have boiler process 2, 3, for example 6. It goes here, and then it goes to turbine, and after turbine we put in condenser in order to create steam in and water and liquid. Yeah, it happens here. So second, as you can see, it's a very old technology, but it improves every year. And as I said, in the beginning, in 19th century, we have efficiency about 7%. Now we have efficiency 30, 35, and maybe 40%. It happens due to the improving elements of such system. So second one, it's a hydroelectricity and hydroelectric power. It's shown here. Yes, we have. I think it's it takes second place in the world. Peculiarity of such hydroelectric power peculiarity that we can say that it's a ecology friendly technology, especially if we speak about not very high power. Yeah. For example, micro turbine from 500 kilowatts until maybe 25 megawatts. It's possible to create a hydroelectric power system without creating some dam. Yes, like it's shown here. But if we speak about high power system, it necessary to create artificial condition of creating such difference level in a reservoir, in this first reservoir and to second reservoir. So it means we put it across the river, normal to the main flow of river water. And here it is, you can see we have intake, penstoke, and here it is, we have turbine. Turbine is connected with generator, and also here it is the river or the second reservoir. But you can see it's a very big power. If we return, here it is. In this moment, we have approximately total generation about 27 multiplied 10 5 watt hour. Yeah, so why 10-15, yes, 10-15, sorry. So the very big values. Yeah, in its consumption of energy in 2019, I think it's not changed very big. And it gives us to very big value in 2020, you can see, and which is more than all other renewable sources combined, and also more than nuclear power, as we said before. And what's interesting for us, that it's possible also to use like a renewable energy, because of course some problems of and disadvantages thermal power stations, that of course it's some exhausted gases, CO2, of course, also some oxides like oxides of nitrogen. It has a big and bad influence on the environment. Yeah, in this case we don't have any exhausted gases. Only, of course, we have some problems with the changing of environment around this station. So, but if we speak for small electric power system, hydroelectric power, it's very good, and it's one of the direction, and it gives a change. It gives a possible, especially in the countries which have a lot of small rivers on maybe lakes. It's possible to create very small hydroelectric power, and they don't, especially don't create such dam. It is a real green technology. I mean, of course, now a lot of hydraulic power has a power about 1 or 2 gigawatts of energy. The biggest one now in the China, it is they have a power about 22 gigawatts. It's very big, of course, but of course such system has a big damage to environment. And third in this there is a traditional energy power plant. It's a nuclear power plant. A nuclear power plant, sometimes it's abbreviated as NPP, is a thermal power station in which the heat source is nuclear reactor. Yeah, so instead of boiler, we have here reactor. Is a typical of a thermal power station, heat is used to generate steam that drives a steam turbine. You can see here it is also like a boiler, water. In some in first level of development nuclear power station, and second second level of development nuclear power station. They used water, but now, of course, some of them it's possible to use natri. But if we return, we can see water receive energy from reactor. It increases power, it increases pressure, temperature, and we put in turbine. Then after turbine, we have again heat exchanger. Here it is a pump, and we have Rankine cycle again. So we have first loop, second loop, and third loop. Here it is reactor vessel. Yes, we have some active zone. In now we have that it's possible to use like a fuel plutonium or uranium, and at this moment about 439 nuclear power reactors works in the world, in 32 countries around the world. So here it is in more details it's shown here. So we can see we have main moments. It's here it is control rods, and here it is steam generator. It's shown here. So of course it's very it's necessary to pay attention to the first loop in order, because here it is we have chain reaction that it goes without any stopping process. It's very hard to stop, of course for this reason it has some additional cooling system for safety and demand. Yeah. If we speak about some thermodynamic peculiarities, as you can see here, it is we have a Rankine cycle 2, and this cooling tower, it's used for cooling water and creating it's usually it's used water put it here, and by air from atmosphere it's cooled down. So some word about fuel. The development of electric power and heat supply is based on the use of various natural energy sources, like organic fuels have occupied a special place among them for a long time. So, and we have organic fuel, it's like natural and artificial. Why we use organic fuel? Because it has a high heat energy of combustion. The heat of combustion is the main energy characteristic of various types of fuel. It is determined by amount of heat that it's released during the complete combustion of unit of mass or volume. The heat of combustion is measured in kilojoules per kilogram or in calories by kilogram. So as we can see from the my first list of presentation, that main fuel in the world now stays a coal, but according to but of course, as we discussed before, we can make classification according to aggregate state of organic fuel, and it could be divided in solid. So we have here coal, brown coals, shell, peat, wood fuel. Liquid, it's oil or petroleum products, like gasoline, kerosene, and fuel oil. And gases, natural gas and methane. So some words about coal. Coal is extremely broad concept that needs very different natural minerals. Common to which is that they are solid and contain sufficiently large amount of carbon in their combustion. So, and according time of saving in the earth, coal could be divided according heat of combustion. So, for example, brown coal, they are young coal. They have about 821 megajoule per kilogram. And middle-age coal, 7027 megajoule per kilogram. And anthracite, it's a very old and very good quality. It's shown here very well now, this picture. This is very the best a coal, and it has about the maximum of heat of combustion. Second, if we continue our talking, oil is a dark brown viscous and oily liquid, and it has higher heat of combustion heat about 45-47 megajoule per kilogram. And light fractions for motor fuels, it's like gasoline, kerosene, diesel fuel, and petrochemical raw materials are obtained from oil by its shallow processing, and the remaining fuel is used as a boiler or furnace fuel. Fuel oil, which is used in thermal power plants, has heat combustion heat about 40-42 megajoule per kilogram. So, and here it is, of course, we can receive different products of oil refining, like gasoline, diesel fuel. It has they are received during some boiling process, and you can see they have a evaporation temperature about 180 degrees of Celsius. It's aviation gasoline, like a kerosene, and diesel fuel has about 270 and 400 degrees of Celsius. And some words about natural gas. Natural gas is the most often found together with oil, and for this reason we have next classification for all deposits is used in according to the ratio in reservoir to the oil. For if we have less than 1000 meter cube of gas per 1 ton of fuel, it's a considered associated gas, and 1 ton of oil accounts for 1000, maybe to 20,000 cube meters of gas. It's considered as gas condensate, and if we have more this value, it's called purely gas gas storage, gas place. Gas condensed deposits contain not only condensate, natural gasoline, but also ethane. Ethane is used like as the basis of polyethylene production, as well as propan butane fraction. It's used like liquid for it's used in liquid condition for fuel for some cars. And we have different combustion heat from 29 until 63 megajoule per kilogram. So and comfortable to use some concept of conventional fuel because we have different types of fuel, but it's like it's shown some standard conventional like a standard conventional fuel we use. And conventional fuel is considered like a fuel with heat combustion about 29.3 megajoule per kilogram. It corresponds to anthracite coal. And if we would like to make conversation of amount of natural fuel, for example, gas, or maybe liquid fuel in conventional fuel, so we use this expression. Here it is BHNM, the amount of natural fuel, and here it is this value Q, the lowest working heat of combustion of natural fuel. For example, an average 330 grams of conventional fuel is consumed to generate 1 kilowatt hour of electricity. And if we would like to receive 1000 kilocalorie of heat, we need to spend about 175 grams of conventional fuel. Sometimes because fuel conventional, so we used a lot of, and we depends, and the world, I mean, the world changing and development has a big dependency from the oil, and for this sometimes it's used oil equivalent. Oil equivalent has this connection with conventional fuel. It means one oil equivalent, yes, is approximately 1.5 conventional unit. So this is sometimes also comfortable to use. Of course, organic fuel consists of combustible part and ballast. Combustible part is a mass of combustible part of fuel is a complex chemical compound and includes carbon, hydrogen, and oxygen, and to lesser extent sulfur, and also it's used for burning process. And ballast, it's a not combustible part, includes some mineral impurities and nitrogen, of course, carbon dioxide, and water. So, and each fuel, also some main parameters, has its own ignition temperature. You can see peat about 225 degrees of Celsius, coal 325 degrees of Celsius, natural gas 800 degrees of Celsius. So, and some interesting maybe moment that last century shows very fast increasing of energy consumption. Of course, energy consumption depends on the number of inhabitants on the Earth, and you can see for in 1950, for one inhabitant and one man in the world, it takes about 1 ton of conventional fuel. And in 1975, this values is increased in 2 tons in the world, in the year, it means in the year, yeah. By the beginning of this century, we have about 5 tons of conventional fuel. and it's increased every time. I think now it's about 6 tons, and the majority of energy needs are met by traditional sources, which include fossil fuels like coal, oil, natural gas. And it's considered that we have about so we have some, if we can make a monitoring of coal and oil and natural gas, it is calculated about 4,000 billion tons of conventional we have consumed for last I think 2 centuries. And of course, the problem is that we need to find new source of energy. If the minimum estimate is true, it means that at the current rate of consumption energy, all reserves of fossil fuels will be exhausted already in the beginning 22nd century. So it means that we have 200 years in order to find new ways of receiving energy. And of course, for this reason, people maybe make returning to the renewable energy. So I think the of course renewable energy, what does it mean? It's the sources are energy resources that are inexhaustible within the time horizon of humanity. And if we consider renewable types of energy can be subdivided like into 3 areas: solar energy, planetary energy, and geothermal energy. I think, of course, you know, from history that, for example, during during a lot of time, for example, people use wind energy for sailing in the sea, oceans, yeah, for meals, and other application. It's used before creating electric power. And for some time, in the beginning of time of coal, and then oil, with the power station, thermal power station development, and car development, we have so people forgot for time for solar energy, for wind energy, and etc. But now it happens due to economical crisis in the beginning 90s, 70s years, 72, 73, when the prices of oil was increased very high. So, and people in Europe, in USA, start, and Soviet Union too, they started thinking about possible way how to save energy. And it's possible to have 2 ways. First of all, it's increase efficiency of power system. So it means, for example, we have sorry.
Ваш микрофон, Дмитрий Александрович.
Спасибо. Okay, sorry. So it means first way we need to increase efficiency of power system. As I said, efficiency in the beginning thermal power station, I think in the middle of last century, I mean power energy and spend energy which we put. About in the 70th years, it was 25%. And now I said that we have about 40%, 40%. It's a second way. Increase efficiency and use, for example, heat of exhausted gases like, sorry, some problem. I'm sorry. Some problems with my PPT. I open it. Sorry. Wait a moment. Okay. Let me. Yeah, I hope you can see.
Yes, we can see.
So is second, and as I said, we have people started using, for example, exhausted gases energy because we have temperature about 300, maybe 400 degrees of Celsius. It's also possible to create some, it's used like hot heat energy, or maybe it could be source for energy for another power plant, and etc. It's the first way. And second way, people start thinking about using renewable energy. And of course, at this moment, it's not right to say that people don't use solar energy. The using solar energy starts from aerospace application from 1950 years, because when Soviet Union launched first artificial satellites, and it's necessary to have some power, but it's not possible to put a lot of fuel at the board of satellite, and for this reason they put some solar and solar panels, and they give a chance to receive electric power for the satellite purposes. Of course, in the beginning, if we think about efficiency of solar power, solar system in 1950s years, it was very small, about 3-4%, but it's the way how to find energy and in the space. And in 70 years, the people return to it and start to use it, also with the wind energy, with the geothermal energy, and etc. Let's discuss and speak about it too. Okay, so solar energy, it's the biggest source of energy. You can see it's a very big energy, about petajoule per year. Yeah, and if we use only 1.1% of its energy, we covers all power that we need for living in the world for all people. If we use this only 1.01% of this energy. Planetary energy, it takes with the gravitation, and sometimes I think you know that using some ocean station with this effect that level of ocean is increased and decreased. It happens in day according moon and Earth rotation. Yeah. And geothermal energy, because inside of our Earth we have that, for example, 1 kilometer, 1 kilometer down, it creates that temperature decreases 3-5 degrees of Celsius. So, and in the center of our Earth, we have temperature about 4,000 degrees of Celsius. For example, the surface of Sun has about 5,500 degrees of Celsius. So it's very big value. So energy stored in the wind or rain, which also can be technically exploited, originate from natural energy conservation. Renewable energy can certainly cover the global energy demand without any problem, as I said. However, that does not mean that transition from our present energy supply to renewable energy supplies will be possible without any problems. On the contrary, renewable energy supplies need a totally different infrastructure compared to what has been created during the past decades. Some moments about it. Of course, we said about solar energy and wind power. As we return, solar energy also is a reason of the reason of that we have a wind in some part of our Earth. Yes, this wind happens due to different temperatures, different spaces in atmosphere with different densities. But the first reason of wind and air flowing is the solar too. Wind power, yes, geothermal, we said. Bioenergy is based on the use biomass energy of plant origin, as well like organic waste from industrial and agricultural production, from some from ocean maybe, and etc. Ocean energy, the ocean is a accumulator, is the biggest accumulator of, one of the biggest in the world, accumulator of solar thermal energy, as well as mechanical energy in form of tides caused by attraction of the moon and sun, as we said before. Okay, so some moments about some general features in renewable energy. Renewable energy during the cycle of human life are permanent and are practically not depleted. Rest are not dependent on resource constraints. Wide geographical distribution. So, for example, as opposite to the local mineral deposits like coal or maybe gas. Yeah. Relative low environmental impact. Relative, because not, frankly speaking, we need to say that we don't have pure ecological way to produce energy in the world now. Maybe we can say about only for small hydroelectric power system. Maybe it's possible to say, but if we have a big system, it has a big and also has an influence, not a very good influence on the environment. Low or renewable energy density, and the most cases, the frequency of supply, not only seasonally but also in daily context. For example, solar, yeah, or wind. The joint work of renewable energy source with the thermal and electric energy accumulators make it possible to equalize power pulsation, store and give energy to consumer in those periods of time when there is no energy flow from renewable energy system. So it means that we need to find also good storage system for it. Yes. Okay. No, you can see the density. Some moment, maybe a moment I need to give it. So you can see the density of energy flow from traditional energy reached about 10 degree, 11 degree watt per meter square, for example, like gas and etc. Or for solar radiation, we have 10.3 watt per meter square, or wind and the Earth surface 10 and 2 degree watt per meter square. So we can see that the density of renewable energy sources about 1,000 million times low than traditional. This is the disadvantage of it. So you can see as a very good picture. Now we have annular solar radiation, if we can see. By far the largest energy resource, as I said, is the sun. Annually 3.9 24 degrees of joule. As I said, people use now consume energy in the year about 4 multiply 10 20 joules. So we can see in 10,000 more than we need. This is and you can see this is global energy demand now. Here it is. It's shown very well, proportional. Yes, coal resource, gas resource, oil resource, and uranium. In other words, as I said, using 1,000 part of incoming sunlight would cover the whole energy, but it's not simple way. So the following technologies can utilize direct solar energy: thermal power plants, photolyzer systems for fuel production, solar collectors for water heating, passive solar heating systems, and photovoltaic solar cells for electric generations. So here this is a scheme of so photovoltaic cells. Yes, we have photovoltaic cells using external photo effect law, and here it is sunlight, and we have transformation electromagnetic waves in direct current. So we have then inverter. Inverter makes direct direct current in AC current, yeah. And then we have fuse box, or sometimes we need to put here storage system. Sometimes we use concentrated solar power systems. They use like lenses or mirrors and special solar tracking system. It's shown here very well. And here it is shown principle of working solar power plant. Yeah. If we return back, and we can see this is again thermal power plant, but instead of oil, instead of boiler, we use here some parabolic collector field, and we use this energy to put for example, it's you can see it shown here. Pump goes here, and here it is. For example, this is absorber tube. In this tube, water goes, but to the tube we have energy concentrated, and it increases the temperature inside. Yeah, and it goes. It means that instead of boiler, we create condition water temperature is increased Yeah, and then we have steam power, and steam goes to the turbine, and we produce electric energy here. So here it is a simple way how to use solar for heating. Yeah, so we have some not water. Sometimes it's used some alcohol mixture, water and C2 H5OH. So, and we have creating also concentrating energy in these tubes. Yeah. Okay, wind power. Wind power, so we can see this is typical wind power system. Of course, it takes some technology from aviation. Yeah, the main moment that we need to have very high altitude of this position. Why we use? Because we have increasing velocity according this law. So R0 and here is 1.7. So it means we have increasing velocity with the increasing altitude, and usually this altitude about 100 meters. Yeah, inside of it we have the rotor and gear rotor blade. It's here it is rotor blade, rotor pitch control, gearbox inside. Here it is generator, and we have connection with the electric systems. So geothermal energy, some words about it. Also, if we pay attention, sometimes, of course, unfortunately, we don't have enough time. Give me 2 or 3 minutes. In comparison with traditional energy, advantage of geothermal power plants include absence of boiler equipment, no fuel costs, yeah, the possibility of using low pressure energy care, and usually we use some water, heat water, or some steam water mixture, and it takes from some production well, like shown here, from some deep zone, and temperature about 150 or 200 degrees of Celsius. And here is the scheme of single circuit geo power plant. It goes here. We have a separation, and water steam goes to turbine, and we have again Rankine cycle. And second one, it's a 2 circuit. When we use, you can see, instead thermal power plant like which use coal and gas, we use this water mixture, steam water mixture. It goes here. We take energy again. Here it is temperature 200 degrees of Celsius, and here it is Rankine cycle. Instead of water, only one peculiarity, we use some mixture, some working substance which can boil at temperature it's low temperature. It could be like freons, like R134A. But it's again thermal power plant, but not we boil. We don't burn any fuel here. Okay. Heat pump. This is a system which technically utilizes low temperature heat in the round, and air is already mentioned in. It's like also it's used geothermal energy. So it means we take some energy from from low source, and during it works like our traditional fridge which we use, but the main purpose is receiving heat energy here instead of cold like wind fridge. Okay, unfortunately it's not enough time. I'm sorry that for some delay. If you have any question, don't hesitate, ask me. I given to you. I hope if you need, I can stay my email address. We can use. You can ask me any question, and I will be happy to answer your question if you want. Okay, ready to your questions.
Professor,
questions?
Dr. Uglanov, thank you very much for your presentation. Could you please then share with us, with the audience, your email in the chat area?
Yeah, please do it. Yes, share my email. Of course, you have my mobile phone too. You can give to your students too. And if you have some private questions, or maybe you would like to ask me about something, I will happy to.
Could you just
do it?
Could you just write down your email in the chat area, please? So that would be the easiest way. If you can do that, please.
I write it now. Wait a moment.
Thank you very much. We have the next.
Sorry. Hope that maybe in the future you can come to Russia. So this is my mail, and for any case, my mobile phone.
So
I use.
We invite the audience to meet Mr. Dmitry Alexandrovich Uglanov in the at the Samara National Research University, the aerospace capital of Russia, within taking a postgraduate course or even in a summer course. I guess we can share to you all these short courses during the summer in Russia. You can meet personally Mr. Uglanov.
Yes, of course, it will be great.
Thank you very much.
Thank you very much. Have a good day. Have a good time, and have a good weather. Because now in Russia we have a winter, minus 12 today. So
okay. Thank you.
Okay.
Thank you.
Bye.
Goodbye.
Bye. Goodbye.
Estimada audiencia, cerramos la transmisión porque inicia otra ponencia en estos momentos. Muchísimas gracias por su participación. La grabación de la ponencia estará en la tabla del festival para que puedan ustedes revisarla. Muchas gracias y buenas tardes.